Welcome to my YouTube channel Rezacat, and today we will see in the electrochemistry topic what is the concept of the standard electrode potential. Okay, what is the concept of standard electrode potential? So what is the standard electrode potential? It is the potential difference which is developed between the metal electrode and the solution. Okay, so standard electrode potential is the potential difference which is developed between any metal electrode and the solution, and the conditions which we have to there for the standard electrode potential are there should be a 1 molar concentration and the pressure should be 1 bar, okay, at a particular temperature. Okay, so these are the conditions for the standard electrode potential. Okay, so we are seeing the electrochemistry topic. Okay, so we will see today the various concepts in the electrochemistry. So our first concept is standard electrode potential. Okay, so the conditions here we have to remember are there this should be 1 molar concentration and the pressure should be 1 bar for the standard electrode potential. Okay, and it is the potential difference which is developed between the metal electrode and the solution. Okay, so suppose that this is the metal electrode, okay, and this is the solution. Okay, so what is the potential difference between these two? That will be the standard electrode potential for the particular cell. Okay, and the conditions are this 1 molar concentration and pressure is 1 bar and at a particular temperature. Okay, so these are for the standard electrode potential. Okay, so then we will see the representation for the standard electrode potential. What is the representation for the standard electrode potential? Okay, so the standard electrode potential, as we know that there are two types of reaction: reduction reactions and oxidation reaction in a particular electrode. Okay, so reduction is at cathode and oxidation is at anode. Okay, so one is cathode, one is anode. Okay, so the reduction reaction in this the gain of electron is there. Okay, so this Zn plus 2 is there, so it is gaining the 2 electrons and making the Zn solid. It is being reduced from plus 2 state to 0 state. Okay, so here the Zn state is plus 2, here the Zn state is 0. Okay, so the Zn is being reduced from plus 2 state to 0 state, and this is the reaction for the reduction reaction of Zn plus 2. Zn plus 2 is going to Zn. Okay, and this is the standard reduction potential, or SRP, standard reduction potential for the this reaction. Okay, SRP, or the standard reduction potential. Okay, Zn plus E naught, how we will represent it is represented by E naught Zn plus 2 hyphen Zn. Okay, so like this it is represented standard reduction potential. Okay, and how the oxidation reaction will be there. Zn solid will be going to Zn plus 2. It is being oxidized from 0 state to plus 2 state, and 2 electrons are being eliminated or released. Okay, and how this will be represented: E naught Zn plus 2. This is the standard oxidation potential, how this will be represented for a particular reaction or a particular cell. Okay, so for in place of Zn, it can be anything. It can be copper also, it can be anything, it can be iron also. Okay, so anything can be there, but the how we will represent it is like this. If iron will be there, how will represent Fe plus 2. Okay, if copper will be there, copper plus 2, like this will be represented, or the copper plus 2 will is going to copper. This is the standard reduction potential reaction. Okay, Fe plus 2 to Fe, it is the standard reduction potential for Fe. Okay, this is for copper. So like this we will represent for a particular reaction. Okay, so these are the representation for a particular cell, how the standard reduction potential or the standard oxidation potential is represented. Okay, so moving further, we will see what is the cell potential. Okay, what is the cell potential? Cell potential is the driving force that pushes the electron away from anode and pull them towards cathode in an electrode. Okay, is called the electromotive force or the cell potential. Okay, so the cell potential is the driving force from anode and pull away from the cathode. Okay, so suppose that this is the anode and this is the cathode. Okay, so what is the cell potential? Cell potential is nothing else but V. Okay, and Q into V is the electromotive force. Okay, so suppose that this is the anode, this is the cathode, and this with some amount of force, this is being the electrons are being pushed down, pushed away from cathode and pulling towards the cathode. Okay, so suppose that this is anode and this is cathode. So these are the electrons which are being pushed from cathode and pull them towards the cathode. Okay, so these are the electrons supposed at anode. Okay, so at with the electromotive force or with the help of cell potential, this will be pulled towards cathode, or that will be attracted towards cathode. Okay, so when it will be attracted towards cathode, it will be done with the help of cell potential or electromotive force. So as the cell potential will be higher, cell potential is higher, electromotive force will be higher. If the cell potential is lower, electromotive force will be lower. Okay, so the rate at which electrons are being attracted towards cathode will be lower. Okay, if the electromotive force is lower or the cell potential is lower, then the rate at which the electrons are being attracted towards the cathode will be lower. If the electromotive force or the cell potential is higher, the rate at which the electrons are being attracted towards the cathode will be larger. Okay, and where the electrons are at the anode, and these are being attracted towards the cathode with because of the cell potential, and the cell potential will be generating the electromotive force will be with the because of that. Okay, so because of this potential, cell potential, or the cell potential, or the it is also the potential difference. Okay, or the delta V. Okay, so this is also the potential difference between the two, and between the two electrodes, anode and the cathode, and because of this delta V, what is there, an electromotive force is generated between the anode and cathode, and because of that the electrons which are at anode are being attracted towards cathode. And if the if the electromotive force is larger, it means that the cell potential is larger of that cell, and if the electromotive force or the rate at which electrons are being attracted towards cathode are lesser, so the cell potential will be lower of that cell. So this is the concept which we have to remember. Okay, for the cell potential. Okay, so next our we'll see in depth what is the electromotive force of a cell. So electromotive force of a cell is equal to the potential difference between the terminals. Okay, when no current is passing through the circuit. Okay, so this we have to remember that no current is passing through the circuit, and then the potential difference, what is the potential difference, that is the and there at that time the potential difference is equal to the electromotive force of that cell. Okay, so this we have to remember that what is the concept for the electromotive force. Okay, that when the no current is passing through the circuit, suppose that this is the circuit. Okay, so when the current in this circuit is equal to 0, so the electromotive force, so the potential difference which is V, okay, is equal to the electromotive force, or it is sometimes QE. Okay, E is the electric field which is the term of physics. So QE is equals to at that time this QE force is equal to V. Okay, so this we have to remember that the current in the circuit should be equal to 0, or it is the initial state. Initial state. Okay, because at the final state current is there. In the final state current is there, I is not equal to 0. So we have to, this is inherent that it is set for the initial state of the system. Okay, because in that state the current is equal to 0. Okay, so this is the concept for the electromotive force. Okay, so the next our concept is cell potential. What is cell potential or the E naught cell? Okay, this we have seen cell potential previously also. Now we will see the how we will represent in terms of the reactions, okay, or the E naught cell is equal to the standard reduction potential of the substance minus the standard reduction potential of the substance which is oxidized. Okay, so this is how, in the terms of reaction, if the reaction is given, how we will find the E naught cell or the cell potential. Standard, it is the standard reduction potential of the substance which is reduced minus the standard reduction potential of the substance which is oxidized. Okay, so this is the representation for the E naught cell of for the cell potential. Okay, so suppose that standard reduction potential of a substance which is reduced is given, and the standard reduction potential of a substance which is oxidized is also given. So we can easily find what is the E naught cell for that reaction. Okay, this is how we will find the E naught cell of a reaction. We will subtract the two standard reduction potential. Remember, we don't have to subtract standard oxidation potential. We will change it to standard reduction potential, and then we will find the E naught cell. Okay, as we have previously seen, there are two types of potential: standard reduction potential and standard oxidation potential. But in this, we have to remember that while finding the E naught cell, we have to see what is the standard reduction potential of the substance which is reduced, and also the standard reduction potential only the which is substance which is oxidized, not the standard oxidation potential. We will change it to standard reduction potential, and then we will find the E naught cell. So this is the mistake, very common mistake which we do, that we don't have to subtract the standard oxidation potential, we have to subtract the standard reduction potential. We have to change it to standard reduction potential, and then we will do the necessary things. And how we will change? If suppose that Zn plus 2 to standard oxidation potential is given, so Zn to Zn plus 2 is given as plus is given as some plus A. So what is the of reduction potential? Zn plus Zn will be equal to minus A. Only the sign change will be there, plus 2 plus A to minus A. If suppose that anything is given, we will just multiply the minus sign with it. Okay, or the we will reverse the sign. Okay, we'll multiply it with the minus sign for changing it to standard reduction potential from standard oxidation potential, or we will reverse the reaction, or we will multiply it with the negative sign. Then we will find the E naught cell of that reaction. So this is the concept how we will find the E naught cell for the reaction. Okay, so the standard reduction potential is the measure of substance or tendency of substance to be reduced. Okay, so this we have previously also seen that the what is the definition for the standard reduction potential? It is the measure of a substance or the tendency of substance to be reduced. Or okay, so this is the definition for the standard reduction potential. Okay, and what is the definition for the standard oxidation potential? Tendency of the substance to be oxidized. So this is the definition for the standard oxidation potential, that this is the tendency of a particular substance to be oxidized. Okay, now we will see that sign of E naught cell will tell us in which direction will the reaction will shift in the equilibrium. So this is the very important concept, that what the sign of E naught cell will tell. Okay, so suppose that sign of E naught cell is positive, so the in what direction the reaction will shift? In the forward direction. Okay, and if the E naught cell is negative, the reaction will shift in the backward direction. So this is what the E naught cell of a particular reaction will tell, that when the equilibrium will be reached, then what direction the reaction will shift. Okay, so suppose that we are starting a particular reaction, and the E naught cell we know. Okay, so when the equilibrium will be reached at a particular time, in what direction it will shift, in the forward direction or the backward direction, we can tell previously only. Okay, so we can tell previously only by seeing the sign of E naught cell. Okay, that in which direction, when the time will be passed and the equilibrium will be reached, in what direction the reaction will shift, in the forward direction or backward direction. So this we can tell with the help of E naught cell previously only. Okay, so this is the help for the E naught cell of a particular reaction. Okay, so now we will see important points for the cell potential. Okay, So there are some of the important points which we have to remember for the cell potential. So important points for the cell potential which we have to remember. Okay, so reactions for which E naught cell is positive. So suppose that there is a particular reaction for which the E naught cell is positive. Okay, what is the E naught cell? Standard reduction potential of a substance which is being reduced minus the standard reduction potential of a substance which is being oxidized. So this is the concept for the E naught cell. Okay, so suppose that E naught cell of a particular reaction is positive, this value is positive, standard reduction potential is greater than the standard standard reduction potential of a substance which is being reduced is greater than the standard being or reduction potential of a substance which is being oxidized. So this quantity will be greater than zero, as this is greater than this quantity, or the reduction potential of a substance which is being reduced is greater than the reduction potential of the substance which is being oxidized. So the reactions for which E naught cell is positive, or the this is being greater than this, then have equilibrium constant that are favoring the formation of products of the reaction. Oh, okay, so the equilibrium constant of that reactions will be favoring the formation of products, or the reaction will shift in the forward direction, as I told. So it will favor the formation of product, or it will be having tendency to shift in the forward direction. Okay, so these are the spontaneous reactions. So now we will say these are the spontaneous reaction, as they are favoring the formation of product. Okay, so if the reaction is being carried in the forward direction with less amount of activation energy or less amount of energy, then we will say that this is the spontaneous reaction. Okay, and if the more energy is being given to the system for being moving forward, so that is the less spontaneous reaction or non-spontaneous reaction. Okay, this is the concept for the E naught cell. Okay, so these are the concept which we have to remember, that if this quantity standard reaction potential of a reduced is greater than this, then it will be good for us, so that the for the formation of product. Okay, since the reaction will shift in the forward direction, or if this is less than this, then the reaction will shift in the backward direction, and if the it is zero, the reaction will be in equilibrium. Okay, if it is equal to zero, then the reaction is in equilibrium. Okay, so this is the concept for the E naught cell or the cell potential. Okay, so let's see one more concept. If the magnitude of E naught cell is the measure of the driving force behind the reaction. As we saw, if the cell potential is higher, the electromotive force is higher. So it is the measure of or the cell potential is the measure of the electromotive force or the driving force for a particular reaction. So cell potential is directly proportional to the electromotive force or the driving force. Okay, so since it supports the reaction for moving forward, or the rate at which the electrons are being attracted towards the cathode. Okay, so the larger the value of the cell potential, the farther or the more the reaction will be reaching towards the equilibrium. Okay, so the if cell potential is higher, the reaction will be more and more and more shifting towards the formation of the product, or more and more the product formation will be there. Okay, this is the concept for the sign convention for the cell potential. Okay, now we will see what is the relation between delta G and E cell. Okay, what is the relation between delta G and E cell? Delta G is what? Gibbs free energy, and E cell is the cell potential. Okay, what is the relation between Gibbs free energy and cell potential? Okay, now we will see what is the relation between these two. So how it is defined? Delta G is equal to W delta W plus V delta P minus S delta T. Okay, so delta W plus V delta P minus S delta T. Okay, this is the relation between the delta G and E cell. Okay, delta G and E cell, or the work done is only equal to the E cell. Okay, so when the T and P are here, the work done is being related with the E cell. Okay, so here where the T and P are constant, so delta P and delta T is equal to 0. If T and P are constant, so delta T is equal to 0 and delta P is also equal to 0. Okay, so these and this quantity are equal to 0, so delta G is equal to delta W, or uh, or the integral of delta G is equals to delta W. Okay, so here the what is the W when T and P are constant? So the W is the maximum work. Okay, so W is W max when the T and P are constant, or delta P and delta T are equal to 0. W is equals to W max. Okay, okay, so this is the maximum non-expansion electrical work. Okay, so this is the maximum work which is being generated from a particular reaction. Okay, so we now the maximum non-expansion electrical work that the system can do is equal to the decrease in Gibbs free energy. Okay, as we saw, delta G is equals to W max. Okay, so the maximum non-electrical work the system can do is equal to the maximum decrease in the Gibbs free energy. Okay, so when the maximum work is being done in the system, it in turn relates to the decrease in the Gibbs free energy. Okay, so when the system work is done by the system, the Gibbs free energy of a system will be decreased. Okay, now this relation, as we saw previously, delta G is equals to W max. Okay, so the maximum electrical work which is being obtained from a cell is equals to the delta G, okay, or the W max. And delta G, how it is related with the voltage of a cell, and Q is the charge. Okay, so delta G is equals to minus Q into V, okay, or minus NFE. Okay, so this is the standard thing which we have to remember, that delta G is equals to minus Q into V, or it is also equals to minus NF into E. So these are the two things which we have to remember, that what delta G is equal to. It is equal to minus Q into V or minus NFE. Okay, these are the two things which we have to remember, where the N is the number of moles of the electron, this we have to remember, and F is the Faraday constant, and delta G is the change in Gibbs free energy. Okay, so these are the three terms which we have to remember: N, F, and E, and delta G. Okay, what is N, what is F, and what is delta G? Okay, so as we saw that delta G is equals to minus Q into V, and also equals to minus NF into E. Okay, and here the 1 Faraday is equals to the charge present in 1 mole of the electron. Okay, so what is 1 Faraday? 1 Faraday is the charge present which is present in the 1 mole of electron. Okay, and the value of 1 Faraday is equals to 96,485 coulomb per mole. Okay, so this we have to remember, that what is 1 Faraday? 1 Faraday is 96,485 coulomb per mole, or it's approximately equal to 96,500 coulomb per mole. So this value we have to remember, that what is 1 Faraday equal to? It is equal to 96,500 coulomb per mole. 96,500 coulomb per mole. Okay, or 96.5 into 10 to the power 3 coulomb per mole. This we will use in various places. Okay, this we have to remember. Okay, and these two formulas are also very important. And what is the 1 Faraday equal to? It is the charge present in the 1 mole of electron. So all things are very important which we have to remember. Okay, so the relation between delta G and E cell. Okay, for a spontaneous cell reaction, or the E naught cell is positive and it is favoring the formation of the product. For a spontaneous cell reaction, as we know that E cell is positive, or the standard reduction potential of the substance which is being reduced is greater than the substance which is being oxidized. Standard reduction potential of the substance which is being oxidized. So delta E cell is 0. So this is only the E cell. This minus this, so so E cell is positive, and E cell is also equal to minus NFE. So delta G is equals to minus NFE. So E cell is positive, so delta G will be negative. Okay, so the delta G is negative here, and for a non-spontaneous reaction, E cell is negative. As we know, this value is less than this, so this is negative. Okay, this is negative, so E cell is negative. Okay, so minus NFE is negative. Okay, minus NFE will be positive, since minus NF into E is negative, and this also a negative sign, so minus into minus, so it becomes positive. Okay, so this is delta G, so delta G will be positive. Okay, so delta G will positive if E cell is negative, since equals to minus NFE minus from the which is being there in the previous, and minus 1 minus from the E. So the delta G will be positive for that reaction which is non-spontaneous. Okay, thank you.